So, for engineers that are working on device development, what would you say the main advantages of using 3D printing to create the complex geometries or the micro-sized components that are otherwise impossible or costly for traditional methods?
We use right now are, they're made by extrusion, and then there may be some post-processing techniques with, laser cutting and you're assembling the catheter, but you're really quite limited in terms of what you can make with extrusion and laser cutting and assembling. And so the 3D printing allows us to sort of completely reimagine what the catheter should look like. So we're not limited by the manufacturing. Say, this is what we need, and then we can just go ahead and make it. So it ended up being sort of a bio-inspired design. We were looking at these scanning electron microscopy images of bee stingers, and the bee stingers have these barbs in them that retain the stinger at the injection site, and then the bee is injecting venom. So we actually looked at this, and we looked at the geometry of the barbs, and we used that as inspiration for the retention mechanism for our catheter, because the catheter has to stay in the tumor. And that's something that would be hard to make using a conventional manufacturing techniques.
So the catheter stays in the tumor just as the port would have stayed on somebody's skin, right? So then the medicine is delivered. So you hook it up to the catheter.
Right. So there's one end of the catheter is in the tumor, and then the other end of the catheter either comes out of the body, and you just have a catheter that's sutured to the skin that is removable once you're done with your treatment, or for longer term treatment, can be the other end of the catheter can be attached to subcutaneous fluid so that there's nothing hanging out. What we're trying to do is to get the immune system to attack the tumor. So this is a very big field, cancer immunotherapy, and the immune system can actually recognize that the tumor is not supposed to be there and can attack it. But in many cases, the immune system recognizes the tumor, but it doesn't attack it. It sort of thinks that maybe it's okay. It's going to ignore it. And so cancer immunotherapy is really trying to convince the immune system, that this cancer, these antigens, this foreign cancer material that you see in the body is really shouldn't be there, and that you should attack it. So we have all of these new medications to sort of rev up the immune system and get it to attack the tumor. And so this has actually been, revolutionary and has really made a big difference for a lot of patients. But a lot of types of cancer don't respond to immunotherapy. And so we wanted to make the immunotherapy more targeted by delivering it directly into the tumor. And if you look at how the immune system attacks the tumor, it's sort of integrating a lot of information, and then it's making a decision about whether to attack or whether to ignore the tumor. And what we need to do is to get the system to decide to attack the tumor. So there are all of these sort of signals. You can sort of think of it as a computer, that the immune system is integrating all of this information and then making the computation and making a decision about whether to attack the tumor or not. And we're trying to convince it to attack the tumor. And we're doing this by delivering these chemical signals into the tumor. And want to basically deliver the right drug to the right place at the right time in order to induce the desired immune response. So we actually tried a number of different 3D printing technologies and had to really push the limits of the technology. And we're basically right up at the limits of what we can make. And so it's really, the material selection is really driven by the technology. So for the microstereolithography, we only had one or two options-based materials that could give us the resolution that we needed.
But I've also been reading a lot about 3D printed drugs themselves. So
yeah, so probably what you're talking about is 3D printing pills to release drugs in a profile. And this is sort of a big field. Basically when you're taking a drug, there's the active ingredient, but there's a lot of inactive ingredients. And it's almost sort of a misnomer. They're not really inactive ingredients. The inactive ingredients are actually controlling release profile of the drug. And the reason you want to do that is, maybe you want to take the drug once a day instead of 3 times a day. Or maybe you want some immediate effect. So you want some drug released immediately, and then you want some sort of sustained release over a particular amount of time. So there's a particular release profile of sort of drug concentration over time that you might want. And so, traditionally you would add these inactive ingredients that sort of release the drug over time. You can put like a capsule. And then there also are these newer 3D printing technologies where if you want something really custom for the release profile, you can sort of print the drug and the capsule and the inactive ingredients so that it releases drugs, basically when you want to release them.
Do you want to give me your opinion on that, on 3D printed capsules?
I mean, the general concept is really good to have sustained release, to have sort of targeted release, and sort of, to reduce the number of pills or the number of injections that you have. And that's one thing that we're working on is, instead of having multiple injections, it would be great if you had a single injection that released stuff over time or released stuff at the correct times. So I think that's definitely good for patients. I think that'll be very beneficial. The 3D printing part, the part that's sort of still a question is whether it can be used in production. Traditionally it's used for prototyping, and if you're going to use it in production, it may be more expensive, and you have to figure out whether you can get the cost to work.
So would you say that there are any specific design techniques or best practices that on the medical side you would recommend for engineers who are aiming to leverage 3D printing for microscale medical devices?
Well, I think the key is really to figure out, at least from my perspective, is to figure out what the medical problem is. And we work very closely with engineers, and it's really a question of, this is what the doctors need to do what they need to for their patients. And here's what the technology can do. And it's actually quite difficult to figure out where do those intersect, because we may want to do something that's just totally possible. Or if you just look at it from the engineering perspective, engineers may have some cool technology, but then we can't figure out exactly how to use it. And so basically we meet with our engineers sort of daily to sort of figure out, this is what the patients need, this is what the technology can do, and can we find where these two things intersect.
Is there anything else that you would like our readers to know about this trial that you have been working on, the research that you've been doing? Anything else?
Yeah, we would love to hear from anyone who has some good technologies that might help cancer patients. And we sort of love working on new things and getting them out of the lab and into the clinic.
Terrific. Well, Dr. Ed Boas, thank you so much for joining us today. It's been very enlightening, and it is a great sense of hope that we get for cancer patients. So I think this is phenomenal technology. Thank you again for being here today, and thank you for joining us. Until next time, I'm Sharon Spielman with Machine Design. Stay curious.